35 people at random that fit in this group and came up with a mean salary of $59,000, that would be very unusual. Other questions? 12? Is that what he said? 12?
Yeah.
Somebody help me out? All 12 is a long one, isn't it?
Yeah. It's, you find the mean and standard deviation of the population, list all samples with replacement of a given size for that population, and find the mean and standard deviation of the sampling distribution, compare them with the mean and standard deviation of the population.
All right, so first thing we're going to do, how can we find the mean of the population? How can we find X bar? There's only like 4 of them in there.
Plug it in your calculator.
You could plug them into a list in your calculator. That's probably the easiest way because we also got to find the standard deviation. But to just find the mean, you add them all up and divide by 4. Somebody help us out and do that. What is that?
207.5.
So that's the mean. Now to find the standard deviation, we're probably going to need our calculator. So somebody, if you plug 200, 130, 270, and 230 into a list, then you do 1 vars, or 1 variable stats, so on and so on. What's the standard deviation? And we want the one that's sigma x. What's that come out to be?
51.1.
So that's 2 of our answers. Now we want to find the mean of the sample means. What would that be?
Same as the mean.
Same as the mean up here, which is 207.5. And then the standard deviation of the sample mean would be 51.17 divided by the square root of what they, we're taking them 2 at a time, is that what they said?
Yeah.
Somebody do that for us.
36.18.
Those are the 4 answers that matter on this one. The other one, I just wanted you to see what they're actually doing. And that was list all the possible samples. You remember when we did this and started class last time? All the different samples that you guys picked. And then we found the mean of each one. I'm going to do this extremely quickly. I'm just going to write these down. I'm probably not even going to write them all down because we want to move on. Our numbers are 130, 200, 230, and 270. And I want to pick 2 numbers from that set with replacement and see what it is. So I could pick a 130 and a 130. I could pick a 130 and a 200. I could pick a 130 and a 230. I could pick a 130 and a 270. Then I could pick a 200 and a 200. I could pick a 200 and a 130. I could pick a 200 and a 230. I could pick a 200 and a 270. Don't need to go any farther. Does everybody see the pattern there that we're doing? So there's going to be, I think there was like 16 of them. I think I've listed 8, so I'm like halfway. The mean, add these 2 together, divide by 2, that's 130. That's 330 divided by 2 is 165. Add these together, that's 360, that's 180. And that's 400, that'd be 200 is the mean. 200 is the mean. 330, that's 165 is the mean. 430 is what, 215 is the mean. 470, the mean of that. What is it? 235, thank you. So on, so on, so on. Now, if I would have done all of them, continued them on, and I went through and found the sum of all these means, it came out to be this. And I actually did it on my paper there. 3,320. how do we find the mean of all these means if I were to list them all out?
Divided by amount would be 16. What did you say?
16 would have been how many? Somebody help me out. What's 3320 divided by 16?
207.5.
Same thing that we got here. All right? So if we found all the possible samples, it's going to come out the exact same thing as we got here. That's what they were trying to show you. I will show you this. That doesn't have anything to do with the problem, but it's got to do with the quiz. If we're going to draw our normal curve for this, what number is going to go right in the middle?
207.5.
207.5. How am I going to find this first number out this way?
Add 51.17.
Somebody help me out. What's 207.5 plus 51.17?
258.67.
Then you're going to do what? Add another 51.7. What's that give you?
309.84.
Ah, hold on. We messed up. We don't want to add 51.7.
36.9.
We want to add this, don't we? My fault. Because that's our new standard error.
243.68.
Then add another one to it.
279.86.
How many do I go out on this side?
3.
Now, what would I do to get the numbers on the other side? Subtract them, fill those in. Does everybody understand that? You're just adding or subtracting this number each time. What should be true about the original graph in relationship to this one? This new one for the sample means should be more what? It's more condensed. All right, so the original graph might look something like this, and this one's going to look, and I didn't draw it very well, something where it's more compact. Next question.
I'm ready.
Riley wanted me to scare you. I said, no, Riley.
Let's make it long
Should be
as
mad
last
at
one.
me.
I've heard you whispering.
The last one was 3 questions.
I know, that's what I'm saying. Hopefully it takes
13,
long.
very
I
similar
won't
to
want to
25,
take the
just
entire class. We don't have
given
any notes.
the directly to you.
Yep.
Okay.
You always get home back.
Not always.
13.
We can't get through the notes.
On 13. Yes. Alexa, answer that one. On 13.
Say so you don't speak in
Don't you just have to find the standard, here,
Find the standard error.
and then find your probability of it happening?
We have to do that in the act.
I got that.
We have to say active harmonious.
They hung up?
Speak
Good. Did you see who it was? A second. And then once you have that, then we just put it in the calculator, and I think I put in negative 10,000. My low limit, 24.3. That's my upper limit. 24 was the mean, and 0.156 was the standard error. And my probability came out to be whatever it was. I'm not sure what the probability said. I didn't write it down. 0.9728. So about 97% of the time. And then they ask us, is that unusual? And we say, no, it's not unusual. Now you gotta be careful, because later on in the year, we're gonna look at stuff like this on this normal curve. And 0.9728 is gonna be way over here somewhere. And if we're looking at just that score, is it unusual for somebody to get that score?
Yeah.
Yeah. Right now, what we're looking at is all the stuff, is it unusual for somebody to score in this area? And we're gonna say, no. But is it unusual for somebody to get that exact score? Yeah, because they're higher than 97% of all the other people. And Riley and Aaliyah, there's none of this on the quiz, but we did something like this.
Is that what we
Aaliyah,
did?
not Aaliyah, sorry, I apologize. That's what happens when you get old. So we did stuff like this. You gotta know that that means the 25th percentile. So that means that the area that we're looking for is 0.25. So we're looking for something in here where down here there's 25% of the data. Other questions on the homework? Everybody's ready?
Yeah.
No other questions?
Yeah, we've been in the hard stuff.
All right. Determine when the normal distribution can be approximate. This should say approximated. Or no, that's right. Can approximate the binomial distribution. So now what we're doing, and I'm going to try to explain this, and as we go through it, you'll understand it. With a binomial, what has to be true for something to be a binomial distribution? Two options, yes, no. Failure, success. All right? When we did the binomial distributions, we had stuff like this, and it came out, where it was sort of normal. And then what we did, and we didn't do a whole lot of this because we used our calculators, and we're going to use our calculators again. But what we were supposed to do is if we were trying to find the probability that something was less than 10 or something like that, then we looked at maybe 10 was right here, and we just added this bar plus this bar plus this bar plus this bar, and we found that whole probability. Now we did it on our calculator, and we typed in 10, and it told you everything to the left. Okay? Now what we're going to do is we're going to do stuff like this, only it's not going to have numbers in it like 10. A lot of them are going to have stuff like 10,000. And if it has 10,000, do you really want to add all these bars up? Again, we used our calculator, so we didn't have to add them all up. But what this is going to allow us to do is instead of doing the bars, we're going to use our normal curve, and we're going to approximate it to that. So those bars will approximately fit the normal curve, but they're not quite. And we're going to have to do one little thing to fix it so that they fit it a little better. That's the main thing. And then, again, we're going to use our calculators to do a lot of it. But a lot of it you can't just, and we can't use the table on a lot of these just because there's so many numbers. You don't want to take this plus this plus this plus this and do like 10,000 of them going all the way down. Or even do 100 of them going all the way down. For a binomial, things that, what made something a binomial? You don't have to skip all that space. I'm not sure why I skipped so much space in between each one. Those are the four things that had to occur for something to be a binomial. Each trial has to be independent. You have two possible outcomes. Your P is always your probability, and that probability is the same for every trial. And then Q is just 1 minus P. So P is probability of a success, Q is probability of a failure. Nothing hard about that, just reminding you what we went over back in chapter 4. This is exactly what we covered in chapter 4. So Jackie can be mad at me because I'm sure she wrote all this down in chapter 4 also.
Should just be happy with not taking that nap.
That doesn't.
Yeah, I know, it doesn't bother you. You don't really care.
Until it's me.
Doesn't affect him
On this, what I would write down on this, the normal approximation. If you just write down normal approximation, what you're going to do here, to be able to do a normal approximation, this has to be the case. We did this earlier this year also, sort of. N times P has to be greater than or equal to 5. N times Q has to be greater than or equal to 5. So if that doesn't work, then we can't use this approximation. These two we did earlier this year also. The mean of a binomial is always just N times P. As a matter of fact, a question like that was on your semester exam. The mean is always just N times P, and the standard deviation is the square root of N times P times Q. And if you wanted to write it down, again, we don't use it very often for this stuff, but the variance, which is sigma squared, is N times P times Q without the square root. So to be able to do this, to be able to approximate to a binomial, it has to be that N times P has to be greater than or equal to 5, and N times Q has to be greater than or equal to 5. When you're doing this, because I'm going to forget to do it all the time, because I just look at it and I say, all right, 0.6 times this times 20, I know it comes out to be more than 5, all right, and so on and so on. So I just do it in my head and I know if it fits it or not. Always take the smallest N, or not N, smallest P or Q. Whichever one's the smallest P or Q, and multiply that times your N. If that's bigger than 5, then both of them work. That makes sense? So in other words, if I gave you something like this, tell me an N. 7. And then tell me a probability. 0.37. All right. What would Q be then? 0.63. Now, instead of multiplying this times 7 and this times 7 and seeing if either one of them is smaller than 5, just take the smaller one. What's 7 times 0.37?
0.59.
Is that bigger than 5? So can we use this on that? No. It doesn't work. All right? Just take the smaller one. If the smaller one doesn't work, we don't care if the bigger one works or not, because we can't do the whole thing. Okay?
So if that happens, what do you do?
But
I doubt that'll happen often.
you put can't use the normal approximation. So what we would do then, and we're going to go over it, is instead of trying to use the normal approximation, we'd have to go back and just use the binomial stuff. And that's on our calculator again. So what this does, we're trying to approximate our binomial to a normal curve. The more or the bigger our N is, the bigger our sample size is, the closer and closer. Look, you see N here is 4, and it's not really a normal curve. Getting closer to a normal curve when N was 10. N was 25. That looks pretty normal. N is 50. Looks real normal. The higher we get our N, the better we can approximate it to a normal curve. The more it looks like a normal curve. So the more we pick in each of our samples, the better off we are. If we just pick 4, doesn't work out too well. If we pick 50, looks real normal, and we could just do this and sort of estimate it using our normal curve, using our what we've been using. Okay, our normal CDF. I don't know why I can't remember that today. Decide whether you can use the normal distribution. So we're just going to make a decision whether we can use it or not on each one of these. 62% of adults in the U.S. have an HD TV in their home. You randomly select 45 adults in the U.S. and ask them if they have an HD TV in their home. What's our N this time? Yeah, now it is 45. I made up this slideshow back before we had. Now you have to have HD TV or nothing works. So N equals 45. What's our probability? 62%. So 0.62. What's our Q then? 0.38. All we want to do, take the smaller of those two, P or Q, multiply it times 45. So what's 45 times 0.38? Say it again.
17.1.
Is that larger than 5? So will the approximation work? Yeah, and that's all we're looking at for this part. We do that, notice they did both of them. If this one's larger than 5, what do we know about this other one? It's going to be larger. No reason to do all that extra math if you don't have to. So then that means, yes, we can do it. Oh, they wanted us to find the mean and stuff. I didn't realize that. So to find the mean, we just take N times P, which we would have done up here, which is 27.9. That's your mean. Your standard deviation, you take N times P times Q, take the square root. We've done this back in chapter 4. Still the same thing. And you get 3.26. From the quiz, what's going to go right in the middle here? 27.9. What do we do to find this first number right here? Add 3.26 to it. What do we do to find this next one? Add another one. Add another. What do we do going down this way? Subtract it, subtract it, subtract it, so on and so on. Decide whether you use normal distribution. 12% of of adults in the U.S. who do not have an HD TV in their home are planning to purchase one in the next 2 years. You guys probably don't remember, but at some point, way back a few years ago, you guys might not even been born then, they came out and told everybody, if you don't have an HD TV, it's not going to work. So you had to buy these special antennas. And then, about 6 months later, they said, all right, the special antennas aren't going to work now. Either buy the TV or just don't watch TV. Okay? No, you can't. You couldn't watch anything on a regular TV. So I don't think I have any more. I think I probably threw them out back and my son's probably shot them. But any of the TVs that we had that were not HD, they won't pick up anything now.
We had a box TV till 3 years ago.
Did it work the whole time?
I mean, the cable worked on it.
Well, see if it's got so it was probably still an HD even though it was a box. So see, that's what I always wanted. I always liked the floor models. Now you can't hardly find them. All right, so on this, what's our N this time? 30. What's our P? 0.12. What's our Q? 0.88. What am I going to do to see if this will fit it or not?
30 times 0.12.
Somebody help us out. 30 times 0.12.
Not greater than 5.
It's not greater than 5, so can we do the approximation on this?
No.
No, but we still can find the mean. What'd you come up with when you multiplied those two?
3.6.
That's the mean. And we can still find the standard deviation, which is just 3.6 times 0.88, and then take the square root of that number. Anybody get all that? 1.78. So that's our standard deviation. That's our mean. And now all we did was we'd have to use the binomial setup instead of the approximation set up. So we can't use normal CDF, we'd have to use the binomial CDF or PDF like we used in chapter 4. .6 was right. Can't use it. And they didn't find it. All right, correction continuity. This is what we're going to do that's going to be different. Before you write any of this down, write that down, correction continuity. Sorry. And under it, all I want you to put on here, add 0.5 to upper limit I should have did the lower limit first. Sorry, I'm running out of space, so I'm going to put this down here. Just subtract 0.5 from lower limit. All the rest of the stuff, that's the main thing. All right? When we do this, what do we put when we make our histogram? What goes here? The midpoint, right? So what we're going to say, let's say the midpoint for this one was 52. I'm just making up numbers. And we want to find the probability of 52 occurring. If we find that probability of just exactly right there where 52 is, guess what it's always going to be? 0. Because there is no area for that line right there. All right? So we don't want to find the probability of 52. We actually want to find the probability from here to there. All right? And let's say this one down here was 51. What's the lower limit down here that we're going from? 51.5. What's the upper limit? So when we put it into our calculator, our low limit's going to be 51.5. Our upper limit's going to be 52.5. That's the correction that we got to make to be able to use this method. So we're not finding just that one spot right there because that line has no area. All right? But we want what's in from here to here, and that's why we subtract 0.5 from the lower limit, add 0.5 to the upper limit. Now the other thing that you got to remember as you're doing this, if we're punching in our calculator and we're putting in 10,000 down here, negative 10,000, we don't have to subtract anything from that because we're just making up an arbitrary end down here. All right, but if we're going up to 25, then we got to add 0.5 to that, so we're going to go from negative 10,000 all the way up to 25.5. So add 0.5 to the upper limit, subtract 0.5 from the lower limit. That's going to correct it so that we're getting the right area under the curve and not just the binomial. That's going to tell your calculator, hey, you're doing it this way.
Can I get a drink, please?
Yes. So, this says the exact same thing. I'm just going to skip over this. This is just telling you what I just said a second ago. Use continuity correction to convert the binomial interval to a normal distribution interval. So if we want to go between 270 and 310, what's our lower limit going to be? 269.5 all the way up to what? 310.5. Be careful, because I heard some of you wanted to say 270.5. We got to subtract off on the low limit, add on to the high limit. probability of getting at least 158 successes. What's our low limit? 157.5, that's our low limit.
158.7.
And it says at least
That was a
158.
bunch in the middle. A bunch.
Do we know how many? So what are we gonna go up to? 10,000 maybe? Lower limit, upper limit. Fewer than 63 successes. What's our low limit this time? Negative 10,000. Probably don't need negative 10,000. We can probably go negative 1,000 or negative 100, whatever. Oops. What's our upper limit? Now, it says fewer than 63. So is 63 getting included?
No.
So this time it's a little different.
So would it be 60.5?
Be 62.5. So on the upper limit this time, we actually had to do what instead of add? Subtract off. All right, because we're really only wanting to go up to 62 because we don't want to include 63. So we went to 62, but then we got to add on that 0.5 there. So you got to be careful when you read it. Sometimes it makes it a little more difficult. To do all this, all you're going to do, step 1, figure out what your N, P, and Q is. Step 2, determine whether it fits the approximation or not. Step 3, find the mean and the standard deviation. So those 3 things, that's all we're doing every single time. Step 4, add or subtract the 0.5 to do the correction. Step 5 says change it to a z-score. We're going to change ours to z-scores?
Probably not.
Probably not. Our calculator does it for us. We're not even probably going to bother with changing it to a z-score. Step 6, find the probability on the standard normal table. Are we going to use the table?
Probably not.
Probably not. We're probably going to use our what?
Calculator.
Calculator. And on our calculator, I'm going to show you that. On our calculator, this is what we do. Very first thing, please make sure you do this. Very first thing you got to do is you got to find the mean and the standard deviation and do the correction. And I probably should have wrote in here, you got to also make sure it works. And what I mean by that is N times P has to be greater than or equal to 5, or N times Q has to be greater than or equal to 5. So you've got to check that first. Again, I always forget to check it because I can sort of look at it and tell, hey, is this going to work? Is it not going to work? Then you're going to use your normal CDF, just like we've been doing. Put in the lower limit, the upper limit, the mean, the standard deviation, and parenthesis. I didn't put the parenthesis on there. I must have been lazy this time, because usually after step 8 was put your other parenthesis in, and you don't want to do that, but like make you do as much work as possible.
Like I didn't even know there was a combo up there. Like I just found out there was a combo on my
Thank you so much for the
last
info.
class I think it was.
That's wild.
Now this works.
You know that announcement?
This works
You know that announcement?
if fits approximation. Doesn't fit the approximation. So in other words, if this is true, if N times P is greater than or equal to 5, and N times Q is greater than or equal to 5, then we can just do this. If it doesn't fit it, then we do this.
Hey, right on that. Hey, reading on that.
Makes it like there's a whole bunch there or something. Find it on there, Riley?
Yeah.
So if it doesn't fit, then we have to use it as a binomial. And if we're using it as a binomial, then you put in binomial PDF in P and X and just do it that way. Now on all of these, if they're binomials, could we do this on every single one of them? If you wanted. The bad thing is, and I'm going to show you that here in a minute, some of your calculators won't do a binomial for some of these.
Wait, whoa. You get a coloring? Mr. Ebersole.
I'm down.
The Pope just sent out.
So,
Word email.
again on this, if it doesn't fit that, we can use the binomial stuff. Even if it does fit it, we could use a binomial, but the normal CDF is probably just as easy, and that's what we've been dealing with. The new calculators, Phoenix was looking at it, oh my God, there's too much. If you don't have the new calculator, did you have to write this part down? No. If you do have the new calculator, you probably know, hey, I just hit binomial PDF, and then it pops up that screen, and it's got, I got to put in my 3 choices. And... All right. The table only goes up to n equals 20. So if you were trying to use the table, which most of you don't even have to worry about this, so I don't know why I put it on here. You probably used the table once when I forced you to use it that one time, and then that was it. It only goes up to 20, so anything higher than 20, we're out of luck. You can use your calculators and use the rules from 4.2. Those were the rules right here that we just wrote down. If it's just a binomial. This is what I want you to do on your calculator right now. We're going to find the probability, have your calculator out so we can check them and so I can see this. Because not all calculators will do all of this stuff, and we got to figure out which ones won't. So our n is 10,000, our p is 0.4, and our x is 9,000. Let's say we want to find the probability that we come up with exactly 9,000. So what we're going to type in, we could do this. Somebody help me out. What's 10,000 times 0.4? First of all, is 10,000 times 0.4 bigger than 5?
Yeah.
Yeah. So is this going to work the approximation? Or fit the approximation? Yes. So we don't even really have to worry about that. It's going to fit the approximation because our numbers are so big. You're going to type in your calculator. You're going to go to normal CDF. We want our low limit. If we want exactly 9,000, what's our low limit? 8,999.5. Subtract off 0.5, right? What's our upper limit? 9,000.5. And I forgot to do something first. First thing we should do is find the mean, which we didn't do. How do we find the mean? It's just n times p. Somebody help me out. What's n times p? What is it? 4,000. Then we got to find the standard deviation. And the standard deviation is square root of 10,000 times 0.4 times 0.6.
48.99.
48.99. Let's just round it off to 49.
Zero. I don't think that.
Punch it into your calculator. What's it come out to be?
The stairs.
0. We're just using a drill.
He's sharpening everything.
0. If your calculator didn't come out to be 0, I need to know.
I had to erase my message from the phone. It popped up, I swear to God. The Pope even signed his name. This is the Pope.
Which one? What's the
There
name?
you go.
Mine comes after zero.
Lily, yours did? All right. Now I need you to do this. Let's do the probability that our number is less than. Yeah, let's do less than 9,000. So now all that's going to change. You guys need to do this on your calculator so I can tell you if your calculator's messing, or not that your calculator's messing up. If your calculator won't do it, there's certain calculators that won't do it, and then we got to fix it. So if we want less than 9,000, what's our low limit going to be? Negative 10,000.
Sure.
We could do that. What's our upper limit? Be careful. 8,000. Right? 8,999.5. And then those two, mean and standard deviation, stay the same. 1. Everybody got 1?
Phoenix, how's it looking?
Yeah.
Everybody got 1, so we're all right there? Try this. Probability greater than 9,000. What's going to change? What's the lower limit going to be this time? 9,000.5. 9,000.5. What's the upper limit going to be? 500,000, something bigger. We probably don't want to use 10,000 this time because we don't know if that's big enough, right? So 100,000. What's the probability that it comes out bigger than 9,000? 0. Is that what everybody's getting?
Oh, I'm gonna have to get the color. I'll put my phone away. I need a coloring thing to focus.
What if I just take the phone?
Okay. Well, what's the difference between me and Phoenix?
I will walk back, because I was walking back there at that point. I will walk back there in a second.
Thank you. You want this one, Michael?
What'd you get, Lily?
Are you done with it?
Zero.
I made it black. I should have made it black. You want it?
Can't remember what it
Hey,
is.
can you use your
There's one of them where it doesn't work. I gotta figure out what it is. Do this. Because on the normal CDF, we could just put in 9,000 and it's just going to tell us that, right? So instead of doing the upper and lower limits, just put in normal CDF, 9,000, and close the parentheses. No, we can't do that because we need the mean and standard deviation only. So put in 9,000, comma, 4,000, comma, 49. Comma 4,000, comma 49.
Zero.
Everybody get 0 on that one? Lily, did you get 0?
I can't really get.
Some of them, and I know Lily's got one of the calculators that's not supposed to work, and now I can't remember what it doesn't work on. But when you get these big numbers, some of them give you an answer like this. So your probability is -1. What do you know about that answer? That can't be possible because probabilities cannot be negatives. All right? All right, let's try one real quick and then we'll be done. 62% of adults in the U.S. have an HD TV in their homes. You randomly select 45 adults in the U.S. and ask them if they have an HD TV. What is the probability that fewer than 20? So fewer than 20. What's our N this time?
45.
45. What's our P this time?
62%.
So 0.62. What's our Q this time?
38.
0.38. Somebody help us out. 0.38 times 4, 5. Is that bigger than 5?
Yeah.
So we're all right to do the approximation. Now we need to find the mean. 45 times 0.62. What's that give us?
27.9.
And then we need to find the standard deviation, which is the square root of 45 times 0.62 times 0.38. 3.6?
No, 2.6.
3.26?
Yes.
Now all we're going to do is we're going to plug this into our calculator. We want, what's the probability that fewer than 20? What's that mean, fewer than 20? What numbers are we including? Are we including 20?
No.
So we want our upper limit to be what? 19.5, and how low down are we going to go?
It's just fewer than 20, right?
Yeah.
Big negative.
So we could do a big negative, or we could just do 0 because
Yeah.
we can't have negative people, right? So in your calculator, you're going to do normal CDF. What's our low limit? 0. What's our upper limit? 19.5. What's our mean?
27.9.
27.9. What's our standard deviation?
3.26.
3.26. So we go out and we randomly select 20 people, or we randomly select 45 people. What's the probability that 20 or fewer say yes, respond yes?
0.005.
Is that, what's that tell us about that?
Yeah, it's very unusual.
It's very unusual because that's about 0.5%. That's very unusual because it's less than 5%, right? Let's see if we did everything right. Notice here they change it all into z-scores, which we didn't do because we don't have to. And they came up with 0.0049. I thought you guys told me it was 0.005.
We rounded.
Oh, okay. Not sure why I put this on here twice. Probably for those people like Phoenix who said, I'm not writing it down, and then figured out.
Just give it.
You're going to write it down.
Oh, hey.
I'll take the second one. He gave it to me.
Who gave it to you? Come over here and take something on my desk.
No.
No,
He slid it over.
I didn't leave my desk.
Did you really not see me stand up when you were in class?
I didn't leave my desk.
Yes. I take my desk and double.
You probably knew it when you
What was that?
Imagine you put it on
Bubble
your phone, I'd be
pencil?
so amazed.
It's because it's really hard dying because of my job in the middle of class.
Yeah.
Like, it's really bad. I told everyone, I was like, I literally could not breathe, and I was trying
Don't out like
not to choke
no.
so loud.
Yeah.
Get your nasty
Oh, I do.
water away from me. Said you were trying not to choke yourself out.
I was literally.
You got like 4 minutes. Somebody wants, help me out, pass those papers back. Several of you.
Goes.
I don't even want the paper.
It's the power I get when knowing everybody's score.
No, literally.
Jack, you got a 30
Yeah.
I never said you weren't. Oh, but is this one?
Benjamin?
Benjamin?
Got a 30
You're
Matthew, while you're up here, do me a favor. Grab the pen and stop the recording.
Simp got a 50.
Hey.
This one.